This is 5.6, lesson 1. So for this lesson, we are going to solve systems of equations. That are already in slope-intercept form, or in that y equals mx plus b form. And we're going to use a method called substitution. So this first situation I give you says, in the world of speed skating, fractions of a second make a big difference. Apolo Ohno became the fastest man in the 500-meter speed skating event during the 2006 Turin Winter Olympics. He completed the 500-meter course in 41.93 seconds. And you can watch the video at the link, which is also on Canvas. So it says, suppose in the last leg of the race, Apolo is behind his competitor. The competitor is 8 meters ahead and is skating at 11 meters per second. Apolo is skating at a speed of 11.9 meters per second. At what time, distance, will Apolo overtake his competitor? So we need to write a system of equations. So we're talking about two people. We're talking about Apolo and we're talking about his competitor. So let's start with the information about the competitor. It says that they are 8 meters ahead, so that's where they begin, and they're skating at 11 meters per second. Okay? Second is usually our x variable, but in this case, we're using t for time and d for distance. So rather than x, we're going to use the letter t, which means that y would be our letter d. So for our competitor, we're going to have d equals 11t plus 8. And then for Apolo, he is skating at 11.9 meters per second. So we're going to have d equals 11.9t as our system of equations. So it says use the graph at the left to estimate a solution. So I would estimate that they are intersecting maybe at 10:120. I'm going to make that my guess. 10 seconds, 120 meters. So if I plug that into my equations, so my first equation, I would do 120 equals 11 times 10 plus 8. 11 times 10 is 110 plus 8 is 118, so that doesn't work. And then if I try the second equation, I would have 120 equals 11.9 times 10, which would give me 119. So this point is close. You might say it might be the point 110. You might say that's better. So if I try that one, and I tried in my first equation, I have 110 equals 11 times 9 plus 8. 11 times 9 plus 8 is 107. So that doesn't work either. So looking at our graph, this is not quite clear cut. So it says, how else have we solved problems when we want to know where two things are equal? Well, we've done graphing, but we've also done tables. So if I do a table for time and distance, and I'm going to go 0 to 10 for both cases. So for my first equation, if I plug in 0, I get 8. If I plug in 1, I get, let's see here, 19. 2, I get 30. 3, I get 41. 4, I get 52. 5 is 63. 6 is 74. 7 is 85. 8 is 96. 9 is 107. And 10 is 118. And then if I do it for my second equation, I would get 0, 11.9, 23.8, 35.7, 47.6, 59.5, 71.4, 83.3, 95.2, 107.1, and 119. When we compare these two tables, we can see that there's not an ordered pair that's listed in both. So our point of intersection cannot be precisely determined from the graph. And so when this case happens, we use something called substitution. So let's take a look at an example of this. So looking at our system equations here, we're going to go ahead and graph these. My first equation, I would begin at -3. And usually I would go down 3, right 1, but that doesn't fit on my graph, so I'm going to go up 3 and left 1. And draw my line. For my second equation, I would begin at +4, and I go up 1, right 2, or down 1, left 2, and we can clearly see our point of intersection. We intersect at the point -2, 3. Okay, so we can always do this by graphing, and we're going to refer back to this to make sure our substitution method is correct. So for substitution, we're doing what the word sounds like. We are substituting something in to our equation. Okay, so in this case, we know what y equals in both of these equations. So for my second one, I know y equals 1/2 x plus 4. That's what y is. So rather than putting y in my first equation, I'm going to substitute these two. Okay, so we're going to rewrite that. Rather than putting y, we're now putting what's in this box. We're going to put 1/2 x plus 4 equals, and we're going to continue writing our equation, -3x minus 3. Now we know how to solve this equation. We're going to get our x's on the same side by adding 3x to both sides. So we're going to get 3 and 1/2 x plus 4 equals -3. We'll subtract 4 on both sides to get 3 and 1/2 x equals -7. Then we divide by 3 1/2 to get x equals -2. Well, that seems to match up with our point, but we still need to find our y. Well, if I know that x is -2, I can go back to my original equation and substitute x, or substitute -2 for x. So we can take our first equation, y equals -3x minus 3. And rather than leaving x as x, I can now say x is -2. And when we solve this, we have 6 minus 3, so y equals 3. Our answer is the ordered pair, -2, 3, which matches up to our graph. So now when you flip the page over, I want us to skip this top part and come down here to the bottom. We're going to use the same method that we did on the front to substitute with these equations. So again, I can look at my second equation. I know y equals 5x plus 23. So I'm going to substitute that in for my y over here. I'm going to replace that y. So we're going to write 5x plus 23 equals 8x minus 4. And then we solve this equation like normal. We'll subtract 5x on both sides to get 23 equals 3x minus 4. We add 4 to both sides to get 27 equals 3x. Divide by 3 on both sides to get x is 9. So we can fill that in our ordered pair. Now that we know that x is 9, I can use my first equation and substitute 9 for x. So we have y equals 8 times 9 minus 4, which is 72 minus 4, which gives me 68. Now just to make sure that we did this correctly, we're going to go ahead and check. And remember to check, we plug in our numbers for the variables in both equations. So rather than writing y, we're going to put 68 equals 8 times 9 minus 4. and we end up getting 68 on both sides, so the first one works. Our second one, we have 68 equals 5 times 9 plus 23. So it's going to give us 68 equals 45 plus 23, which is 68. So that works out. Okay, so when we look at number 3, we're going to do the same thing. We know that y equals this over here. So we're going to substitute that in for y in our other equation. So we're going to have 42.7x plus 596 equals 84.3x minus 28. Subtract 42.7x from both sides to get 596 equals 41.6x minus 28. Add 28 to both sides to get 624 equals 41.6x. We divide by 41.6 on both sides to get 15 as our x. Then we're going to substitute our x into our first equation. You can really do either. It's completely up to you. So we're going to have our first equation here. But rather than writing x, we're going to substitute in 15. So that is going to give us 1,236.5. Just to save some time, we'll skip the check part of this problem. So let's go ahead and go to our third page here. So our third page, we have a little bit different types of problems, okay? So looking at this one, they do not both say y equals. However, we do have one of our equations where y is by itself. So since it is by itself, we are going to use this part right here and substitute it in for that y. Okay, so let's look at an example like that on letter B. We have these two equations, and we have one letter that's by itself. Even though the letter's not y, it'll still work. We know that x equals negative 8y plus 1. So over here, rather than keeping it as x, we are going to substitute in our other problem. So we're going to have 4 times negative 8y plus 1 plus 7y equals 104. And we can still solve this. We're going to distribute so that we get negative 32y plus 4 plus 7y equals 104. Then we're going to combine our like terms to get negative 25y plus 4 equals 104. We will subtract 4 from both sides to get negative 25y equals 100. Divide both sides by negative 25 to get y equals negative 4. Now we still need to find what x is. So we can plug y into our first equation or our second equation. It doesn't matter. I'm going to tell you in this case, though, it's going to be easier. You have less steps if you plug in y to this equation because x is already by itself. So we're going to do negative 8 times negative 4 plus 1. That's going to give us 32 plus 1, which is 33. So our final answer is the ordered pair 33, comma negative 4. So let's try one more of these. On letter C, we see this time that y is by itself, which means that we are going to be substituting this part of our equation in for y on our first equation. So we're going to have x minus 6 times 4x minus 2 equals 35. We're going to distribute our negative 6 so that we get x minus 24x plus 12 equals 35. Combine our like terms to get negative 23x plus 12 equals 35. Subtract 12 on both sides to get negative 23x equals 23. Divide both sides by negative 23 to get x is negative 1. Again, we still need to find our y. So we're going to substitute our x or plug in our x into one of these two equations. It's completely your choice. That will give you the same answer. However, since y is already by itself here, the second equation is going to allow us to do less steps to figure out what y is. So we're going to substitute negative 1 for x. So we get y equals negative 4 minus 2. So that gives us y is negative 6. We must remember to rewrite our final answer as an ordered pair. And our final answer is negative 1, comma negative 6.